A massive climate phenomenon is brewing over the Pacific, and it could turn the weather worldwide upside down. La Niña is on the doorstep and may bring extreme weather events with it. In this video, we take a close look at what exactly is coming and what effects it may have worldwide, so stay tuned until the end. Welcome, friends. La Niña is on its way and it's going to be wild. If you're as fascinated by freak weather as I am, then subscribe to the channel and activate the bell. It's absolutely free and you won't miss any more scientific news. Thanks a lot, guys. According to the latest expert forecasts, La Niña will develop a little later than originally thought. Instead of appearing in early summer as expected, the phenomenon is now expected to occur between August and October. But what exactly is La Niña and why is it so important that we know about it? La Niña is part of a larger climate phenomenon known as the El Niño Southern Oscillation, or ENSO for short. Think of ENSO as a giant climate seesaw that swings back and forth between two extremes, La Niña on one side and La Niña on the other. In between, there is a neutral state in which the swing is, so to speak, in the middle. While El Niño causes warmer water temperatures in the eastern and central Pacific, La Niña is the exact opposite. During La Niña, the water in this region cools down, and believe me, these temperature changes are anything but trivial. We are talking about deviations that can have far-reaching consequences for the global weather. Of course, you're going to ask what specific effects La Niña can have. To answer this question, I spoke to Professor Dr. Andreas Fink from the Institute for Meteorology and Climate Research at the Karlsruhe Institute of Technology, and he is a renowned meteorology expert. I found a quote from you in which you said that overall, La Niña could make absolute heat records less likely in our region. Why is that? And why does something like La Niña, which originates in the Pacific, have any influence on the planet at all?
The fact is that the direct influence on the weather, for example high pressure systems, heat waves, cold waves from El Niño or La Niña on Europe, cannot be statistically proven. We are simply too far away from this region in the Pacific. What we do know, however, is that during an El Niño event, for example, the global mean temperature rises by 0.1 to 0.2 degrees. Because less heat is stored in the particularly tropical oceans, not only the Pacific but also parts of the Indian Ocean. And conversely, during La Niña, the global mean temperature falls by 0.1 to 0.2 degrees. We are currently observing this, although we are still in a very warm year. And from this, we can simply say that, statistically speaking, if the entire globe tends to be somewhat cooler, it is highly likely that we will no longer see these weather extremes that we have seen in Europe, for example. In recent months, we have regularly had the highest temperatures we have ever measured, and there should be some relief. But the specific weather pattern is not measurably influenced here.
It is so minimal that we no longer have record values. Understood? I always live in Syracuse in Sicily for 3 months every year, and that was exactly the place where I think the European heat record was broken 2 years ago with 48 degrees, which was a very pleasant day, so this time we only reached 47 degrees. Very interesting, isn't it? In this video, I will include a few excerpts from the interview. Please feel free to write to me in the comments if you are interested in the full interview. La Niña not only affects our local weather, but this phenomenon can also lead to extreme weather events worldwide. Let's take a look at what different parts of the world could expect. In North America, La Niña leads to a colder and wetter winter in the northwestern United States and Canada, while the southern United States tends to experience milder and drier winters. For all you skiers out there, there could be more snow in the Rocky Mountains. On the other side of the Pacific, in Australia and Indonesia, La Niña often causes above-average rainfall. That sounds good at first, but it can also lead to devastating floods. Do you remember the catastrophic floods in Australia in 2022? They were probably related to a strong La Niña event. In Asia, La Niña can lead to a stronger monsoon in India and Southeast Asia, which means more rain, which can be good for agriculture, but also increases the risk of flooding. What does all this mean for our global climate? La Niña usually has a cooling effect on the global average temperature, which may sound good at first, but it is more of a temporary cooling. And now some of you may say,
didn't we just have an El Niño?
Yes, and that's nothing unusual. The ENSO is a cycle that repeats itself every few years. El Niño is often followed by a neutral phase and then La Niña. It's like a climate dance in which the Pacific temperatures move to the rhythm. What makes this time particularly interesting is the timing. We are currently in a phase of global warming, and the question is, how will La Niña affect this context? Will it temporarily slow down the warming trend, or will the effects of warming overlie the typical effects? These are the questions that scientists around the world are asking, and that's why it's so important that we keep a close eye on La Niña, because every new ENSO event provides us with valuable data on how our climate system works. And it's important for predicting extreme weather events. From droughts to hurricanes, many of these events are blamed on El Niño and La Niña, but can that really be true? Let's hear what Professor Fink has to say about that. You often read about it, but it can also be exaggerated. It can cause droughts or tornadoes. Is that true, or is it grossly exaggerated?
First of all, it is true that the regions bordering the Pacific have a more pronounced statistical impact. For example, the area of Indonesia, northern Australia. I have to say again that this is always a statistical correlation, which means that it happens in 6 or 7 out of 10 El Niño years. For example, they tend to have droughts during El Niño, and in extreme years we have had forest fires in the rainforests of Indonesia. We then have particularly dry conditions in northern Australia. Now, with La Niña, we expect more precipitation in this region, and then, of course, there are other regions in South America, in parts of the United States, on the Pacific coast, and even Florida, which also feel such significant interactions. But it is particularly true in the mid-latitudes. The further away, the less influence La Niña has. However, in the tropical belt, there are Walker cells, which are cells that rise and then flow apart along the equator at altitude, and then sink in other tropical regions. One of these cells is in the Pacific, but there is also one in the Indian Ocean, which affects East Africa and parts of Southern Africa. And we know that during El Niño, the area around Kenya and the Horn of Africa is significantly wetter in the winter of the Northern Hemisphere, but in Southern Africa, it is significantly drier. This happened again last year, but it was hardly noticed by the world. Extreme drought in parts of Zambia, in northern Zimbabwe, where a state of emergency was declared, and this was also predicted by this El Niño. So droughts and floods are connected in certain regions. Another point that is often cited and is also very well known is the effect on the Atlantic hurricane season. The fact is that during an El Niño warm event in the Pacific, there tends to be fewer hurricanes in the Atlantic and more during La Niña. So La Niña makes the Atlantic, where hurricanes form, warmer than it has ever been in the past. And that is why there is a fear at the moment that we will see a very active hurricane season in the Atlantic. We already have the storm Beryl, which was the strongest storm ever to occur so early in the year, so there is this influence on hurricanes. There are also influences on tropical cyclones and typhoons in the Western Pacific. At the beginning, you said tornadoes. To be honest, I have not yet recognized any tornado effects, or at least I am not aware of any. These are thunderstorm cells, very local phenomena, and I am not aware of any way of identifying La Niña as the culprit, so to speak.
I was probably a victim of advertising propaganda, because this movie is currently showing in cinemas, Twisters, and it's about tornadoes in the USA, and I saw the movie poster, but I probably meant hurricanes. Talking to Professor Fink made me realize once again what a fascinating phenomenon the ENSO is. It shows us how complex and interwoven our global climate system is. A temperature change in the Pacific can have effects that we feel on the other side of the globe. It's like a huge puzzle where all the pieces are connected. Please feel free to write to me if you want to see the whole interview with Professor Fink. And to make sure you don't miss it, don't forget to subscribe to the channel now, and you can find another exciting topic in the video show and be sure to click on it. Otherwise, I'd say see you in the next video. Take care, guys.